Okay, students, so we're here with phase 2 on proofs about segments, all right? A lot of new skills we learned. That's why we're taking 2 days to learn it, all right? So we're going to review some stuff, segment, addition, postulate. Let's make sure we draw a picture, all right? So here's 2 points. Here's another point. Do Y-E-S. We spelled yes. That's about as creative as I can be on the top of my head. Now remember, the segment addition postulate states that Y-E plus E-S equals Y-S. All right, I'm allowed to say this left part plus this right part equals the whole stinking thing. Segment addition postulate. Hopefully not too mind-blowing. All right, so just warming up our brains about segments. That's all we're doing right now. Next, what do we got? We got segment AC, or AC and BD are the same. So again, since we got a lot of points going on, I'm just going to do some squiggly marks saying, well, these two portions are the same. Now it's telling me 18 is that much. So that means BD will also be 18. We already said they're equal. So that's what's helpful about labeling a picture. Just things kind of start to fall together. Also, it's telling me that BC is 4. Now clearly 4 is bigger than, or it's not, the ratio is kind of messed up. BC looks more than half of AC, but it's only 4. Pictures are primarily there for visual representations, just so we see what information we have, what information we don't have. And then saying, what's CD? So basically, by labeling our picture, we can quickly say it's 14, or CD equals 18 minus 4, and that's how I got 14. All right, so this was just kind of a numerical warm-up of labeling a picture and determining what information we have and what information we can find. All right. And then in the line segment above, how do we know BC is equal to BC? So how do we know that this segment right here, BC in the middle, is congruent to itself? Remember, we have a property, and that's the reflexive property. That's going to be really important later on. In Unit 4, we're going to use it a ton. All right? So remember, when we do a 2-column proof, we got things. We got statements. It's what we know. And then reasons are why we know it. Okay, so just kind of prepping our brains, and now we can dive into a proof. Uh-oh, this one's completely empty. We got to do everything by ourselves. All right, not too scary. Let's just take it one part at a time. It's telling me AB is equal to CD. So I'm going to draw the tick marks on the picture. Remember, that's incredibly important. And also I'm going to say AB is equal to CD. And that's a given. Now our punchline is say that AC is equal to BD. That's our punchline. Well, I'm allowed to add things to both sides. So I'm going to take BC. I'm just going to add it to both sides. That's all I did. Added BC to both sides. I took the statement above and I added BC to both sides, and since I'm adding it to both sides, it's the addition property of equality. Typically we just write addition though. Okay, so why did I do that? Again, I've done proofs for a long time. It kind of like, what's going on? Just stay tuned. More practice will get better. Just like anything in life, the more you practice it, the more you'll get better. Well, we need to look at our punchline. I need to talk about AC and BD. So we can almost reverse engineer this proof. We can look at the end, look at the conclusion, and think, how can I get there? That's reverse engineering. Well, looking at AC, I can just say AC is equal to AB plus BC. All right. And now it's a segment addition postulate. Alright, similarly, I can do it for BD. That's a great way just to introduce BD, because I need it in my final punchline. BD is equal to BC plus CD in segment addition postulate. All right. So, what can I do from here? In fact, I think I might have done one too many steps, but that's okay. AB equals CD. So I'm going to take CD here, and I'm just going to substitute it in. Alright, so I get BD equals BC plus AB substitution. Alright, and there's a couple of things I could do from here, but really what I'm just going to do for my punchline is say, well, BC, AB plus BC, there's an AB plus BC here, equals AC equals BD. Since they equal the same thing, they must equal each other. Transitive. So this is kind of a good point. I had this point predetermined. There's more than one way to prove something, alright? So this wasn't probably the most efficient proof, but we still got to the punchline. So if you're ever doing a proof by yourself, it might be a little too long at first. But that's how math has always been. Sometimes they state too many stuff, they prove something to be true, and as we progress in math and make more advancements, the proofs become shorter and shorter. Alright, so there's more than one way to prove something to be true. This is just one way. Alright, stay tuned for more videos.